Why is filter order crucial for analog filter design? Imagine trying to listen to your favorite song but with a lot of background noise. You want to block out the noise while keeping the music clear. That's what filters do in electronics. They help us pick out the signals we want and block the unwanted ones. Now, think about how sharp that filter needs to be. That's where the filter order comes into play. Filter order is the number of reactive components like capacitors and inductors in the circuit. It also equals the number of poles in the filter's transfer function. The higher the order, the more complex the filter. But it also means the filter can do a better job at separating signals. For example, a first-order filter has a gentle slope of 20 decibels per decade. This means it reduces unwanted signals gradually. But sometimes, that's not enough. In many real-world applications, we need a sharper cutoff. Increasing the filter order makes the slope steeper. A second-order filter has a slope of 40 decibels per decade, and a third-order has 60. This means the filter can more precisely block out frequencies outside the desired range. That's very important in signal processing and control systems where keeping the signal clean is key. Higher-order filters also change how the signal behaves in terms of phase and timing. They can cause more delay or distortion, which might be a problem in some systems. Different types of filters like Butterworth, Chebyshev, or elliptic have different trade-offs. Butterworth filters give a flat passband but need a higher order 4 sharp cutoffs. Chebyshev filters can cut off more quickly but introduce ripples. Another thing to consider is the complexity and cost. More components mean a more complicated circuit. This can lead to higher costs and more chances for component tolerances to cause issues. Also, higher-order filters may introduce more phase distortion, which can affect the stability of control systems. So, the importance of filter order lies in how well it can separate signals, how it affects the timing of the signals, and how complicated the circuit becomes. Choosing the right order is about balancing the need for sharp filtering with practical limits like cost, size, and stability. It's a key decision that impacts the overall performance of analog filters in signal processing and control systems.